Hi guys, welcome to week 2. Today we are going to start kind of the second half to our unit, but really what we're going to do is we're going to be using all of those properties that we've been working on in order to prove different types of quadrilaterals. So in the past we've asked you, like, is this a square, is this a rectangle, and how do you know? Well, now we're going to kind of go down to the basics. What do we use to write a formal proof and formally be able to say, yes, this is a parallelogram because of this property? So the first one we're going to start with is being able to prove that a quadrilateral is a parallelogram. So this is really the first one that we started with when we were looking at the properties. So we're really going to kind of look at the same order here. So there's 6 different ways we can prove that something is a parallelogram. And the first one is going to be by looking at that definition of a parallelogram. So the first way is if you prove that both pairs of opposite sides are parallel. So just to kind of look at that visually, we know that that is the definition of a parallelogram. So that as long as we're given that these opposite sides are parallel, then that is enough to say that we have a parallelogram. All right, the second one is going to be pretty similar. It's going to say if both pairs of opposite sides are congruent. So in this one, I'm going to, again, just kind of draw off to the side, and I want to do just kind of a mini proof for this one. If I know that my opposite sides are parallel, I'm going to switch colors here. What I could do is I can draw in the third side, and now what I have is I have 2 triangles that are congruent by side, side, side congruence. So just by drawing in one of those diagonals, I can create side, side, side congruence. So that means that the corresponding angles are going to be congruent. So I'm going to have, I can just mark all of my corresponding angles congruent. And really, I don't have to mark all of them. I could just mark those 2 connected to my diagonal. And what's going to happen here is, since I know that opposite interior angles are congruent, that means 2 of my sides are parallel by the converse of my alternate interior angles theorem. And I could repeat the same thing with the other 2 alternate interior angles being congruent. That proves that my other 2 sides are parallel. All right, the third way that we can prove that a quadrilateral is a parallelogram is if both diagonals bisect each other. So I'm going to draw this one out as well and do just kind of a quick mini proof. And I'm going to draw a parallelogram with both diagonals. And if I say they're bisected, that means I have congruent parts on each one. So in order to prove this, what I can look at is that in the middle here where my diagonals meet, I have vertical angles. So now I have triangles, And you could look at the top and the bottom triangle or the left and the right triangle, but those are going to be congruent by side angle side congruence. And very similarly to what we did in the one above, now I know corresponding parts are congruent, so I could draw in those corresponding angles being congruent to one another. And again, I'm going to have that converse of the alternate interior angle theorem that's going to tell me that my opposite sides are parallel to one another. All right, the fourth way is if both pairs of opposite angles are congruent. So if I draw a parallelogram with my opposite angles, both pairs being congruent, that's going to be my fourth way. The next way is if all pairs of consecutive angles are supplementary. So hopefully this one makes sense as well. So if I just put in some arbitrary angles that are supplementary. So I'm going to say if I have one angle that's 60 and one of the consecutive angles is 120, then what I'm going to have here is two supplementary angles. Well, these would be same side interior angles. So that would be the converse of my same side interior angles theorem would say that I have two parallel lines. Well, if all pairs of consecutive angles are supplementary, then I would have to have the next supplementary angle or the next consecutive angle be 60 degrees. And then again, I have same side interior angles being supplementary, which again proves parallel lines. All right, and the last way, and this is kind of the least intuitive way I would think, so we are going to do a proof of this last one next. If we have one pair of sides congruent and parallel to each other. So if I draw a parallelogram, then I'm going to have one set of sides parallel and that same set of sides congruent. And that is enough to prove that a quadrilateral is a parallelogram. So these are all 6 of the ways that we can prove that a quadrilateral is a parallelogram. And so now I want to go ahead and move on to this next piece down here. And I'm going to kind of put a star next to each one so that you guys recognize that these two go together. So this proof right here is actually proving why the 6th way works. So we're going to just set up a formal proof like we usually do. I'm going to put my statements and my reasons. All right, so my first statement, I'm going to go ahead and write out my two givens. So let's go ahead and read this first. So we're going to use the definition of a parallelogram to prove the following properties. So given that side BC is parallel to side DA and segment BC is congruent to segment DA, we want to prove that ABCD is a parallelogram. So my first statement is going to be those givens, so that segment BC is parallel to segment DA, and that segment BC is congruent to segment DA. And my reason number one is going to be given. All right. Statement number two. So just kind of what we have been doing in the past is we've been looking for, are there vertical angles, or is there a reflexive property anywhere in here that maybe we could look at next? What we do have a reflexive property. We can say that segment CA is congruent to segment CA by our reason number two, the reflexive property of congruence. And I'm going to go ahead and mark that in my image. All right. Number three, our statement three, we're wanting to prove that we have a parallelogram here. So since we already know that segment CB is parallel to segment DA, we have to prove that segment CD is parallel to segment BA before we could say that this is a parallelogram. So thinking about what do we want to prove, or how can we do that? Well, we want to think about what are the ways that we can prove lines parallel. So we're thinking about the converse of those theorems. So the converse of alternate interior, we would do converse of alternate exterior, but we don't have exterior angles here. Same side interior. So those are going to be what we're wanting to use. So as we're going along, kind of think about, that's our goal, is to get one of those converse theorems that we can use to prove. So I actually have alternate interior angles in this image. Since I already have two parallel lines, I can say that angle BCA is congruent to angle DAC, and my reason, that reason number three, would be the alternate interior angles theorem. So if we see, we have DA and CB are parallel with our diagonal of CA as our transversal. So then we have angle BCA is congruent to angle DAC. Well, hopefully you guys see right here, we have two sides congruent, or I'm sorry, try that one more time. Two pairs of sides congruent and their included angle congruent. So for my statement 4, I can say that I have triangle DAC congruent to triangle BCA, with my reason for being the side angle side congruence. All right, and then number 6, now I have two congruent triangles. So I know that I can use my CPCTC So my corresponding parts of congruent triangles are congruent. So which angles are going to be helpful in proving congruent? Well, if I can prove that angle ACD is congruent to angle BAC by the by the CPCTC, then number 7, and I'm going to mark that in my image again. So I marked those two angles are congruent. Then for number 7, what I could say is I could say that segment CD is parallel to segment BA, and my reason would be the converse of the alternate interior angles theorem. I somehow skipped number 5. It's all right. We're just going to keep going. We're going to just say the next one's 8. It's okay. Then number 8, since now I've proven that my other two sides are parallel, now I can say that ABCD is a parallelogram by the definition of a parallelogram. So now you guys can see if we're given one pair of sides that's congruent and parallel, we can prove that we do have a parallelogram. All right, so what I want to do for the rest of our lesson today is I want to do these next 5 problems. So these next 5 problems, we are wanting to determine if the figure is a parallelogram. So in numbers 1 and 2, we're given some different values for angles and diagonals, and we have to see if those fulfill one of our 6 ways. And then numbers 3, 4, and 5 give us some congruencies and parallelogram and parallel sides, and we have to determine is that enough to say that they are parallelograms. So what I'm going to have you guys do right now is I want you to pause the video and try the 5 of these. And then once you're done, once you've completely tried all 5 of them, then we'll come back together and we will go through all of them. Okay, so number 1, we are given a parallelogram with different angles. So we have A, B, C, D, and we are given that x equals 9 and y equals 11. So what I'm going to do is I'm just redrawing that parallelogram A, B, C, D below so that I can solve for these angle measures and write them in. So angle A is 8x. So if x is 9, then that angle is going to be 72 degrees. B, we had 10y minus 2, so that's going to be 108 degrees. Angle C is x squared minus 9, so that's going to be 72 degrees. And angle D is 9y plus 9, which is going to be 108 degrees. So, is this a parallelogram? We could say yes, because both pairs of opposite sides, of opposite angles are congruent. Awesome, so let's take a look at number 2. In number 2, we are given measures for parts of our diagonals. So we're given half of our diagonals, and we have to determine, is this a parallelogram? So I have H, G, F, E, and that point where my diagonals intersect is I. So HI is 2A, where A is 4.3. So that is going to be 8.6. IF is 0.5B plus 1.1, where B is 13, so that is going to be 7.6. Well, hold on here. We can already see that our diagonals do not bisect each other. So if we look back up at our properties, the third one here said that both diagonals have to bisect each other. So we could say that no, this is not a parallelogram because the diagonals do not bisect each other. All right, let's go down to number 3. Number 3, we are given that parts of our diagonals are congruent, but it's not parts of the same diagonal. So in this case, we're going to say no, this is not a parallelogram, and it's going to be the same reason as above. The diagonals do not bisect each other. Or we don't know whether or not they truly do bisect each other. So we can't say that these are, or that this is a parallelogram. All right, number 4, this one's going to take a little bit of work to get the answer here. So we're given that we have parallel sides, and we're given that one of our diagonals is bisected. So what we can do here, we have a couple options. Is we want to see if we could prove any of these 6 ways. So when I'm looking at this, the first 2 things that I notice is I notice that I have vertical angles with angle 3 and angle 4. So I know that angle 3 is congruent to angle 4 because they're vertical angles. So by that vertical angles theorem. I also notice that my 2 sides are my parallel sides. So that makes angle 1 and angle 2 congruent. And that's going to be by the alternate interior angles theorem. So now what I have is I have these 2 triangles on the side are now congruent by angle, angle, side congruence. And so what I could say is now I can say in my other diagonal that each of the halves of my diagonal are congruent by CPCTC. So I can say yes, this is a parallelogram because the diagonals bisect each other. And number 5, if we're looking at this, we are just given information about our angles. We are given that we have 2 angles that are x and 1 angle that is 180 minus x. So if I look at the 6 ways to prove, I have a couple ways that deal with the angles. I have one that says both pairs of opposite angles are congruent. And I have all pairs of consecutive angles are supplementary. So if I look at this, are both pairs of opposite angles congruent? Well, looking at the two opposite angles that I know, we don't have enough information to tell us, yes, those are congruent. So we're going to have to say no. We don't have that for sure. And then are all pairs of consecutive angles supplementary? Well, if I look at the top two angles, those are going to be supplementary because x and 180 minus x are supplementary. But if I look at the left side, I have x and x. Well, I don't know if x is supplementary with x. So I'm going to say I don't have enough information to say that all pairs of consecutive angles are supplementary. So I cannot say that 5 is a parallelogram because I don't have enough information. So I'm going to say no, not enough info. I want you guys to think about for a second, what would x have to be in order for this to be a parallelogram? What are options for x in order to make a parallelogram? So if you guys think, if x is 90 degrees, then it would be true. But since we don't know that, we can't say for certain if this is a parallelogram. All right, guys, so that is all the notes that we're taking today. So what I want you guys to do now is go back to the Google Classroom, and there is a quizzes on there for you guys to take. So you guys to go ahead and take that quizzes, and it focuses on the properties of quadrilaterals. It does not have this proof aspect yet. Tomorrow we will start kind of going through some proofs together and having you guys try some on your own. So today we're just going to have you guys do a quizzes that review some more of those properties. All right, let me know if you guys have any questions.